All right, solubility rules. What's the point? What you're basically trying to do is figure out if you put an ionic compound in water, will it dissolve or not? Will it dissociate into its ions or stick together? So the solubility rules can be broken into 3 different parts. So there's rule 1, rule 2, and rule 3. Rule 1 takes part of rule 2, which takes part of rule 3. So you're going to look at it sequentially when you're figuring out if something is soluble or insoluble. So what's rule 1? Any compound involving ammonium, group 1A elements, nitrates, acetates, and perchlorates are always soluble. And I mean always soluble. So group 1A element, sodium, automatically soluble. You don't have to look at what the anion is, it doesn't matter. Potassium sulfide, group 1A element, automatically soluble. Ammonium chloride. Ammonium is one of the rules for this, so automatically soluble. Lithium acetate, group 1A element and acetate, that's a double, so definitely soluble, right? Calcium nitrate, there's your nitrate ion, automatically soluble. I don't even care that there's calcium involved. Aluminum perchlorate, perchlorates involved, automatically soluble. So if any of these are present, automatically soluble, don't analyze it. If rule 1 doesn't apply, then you go rule 2. So rule 2, it looks for -1 charges. So things with a -1 charge anion attached. So for these, there's only certain exceptions. So hydroxides, if it's involved, you can look at it closely. If it's chloride, bromides, and iodides, look at it closely. Anything else with a -1 charge, automatically going to be an S. So let's look at the exceptions. So for hydroxides, if it's any metal not in group 1A or 2A, it's going to be considered insoluble. So group 1A and 2A are the only times hydroxides are going to be soluble. So let's take a look at that. Iron 3 hydroxide, not group 1A or 2A, so definitely insoluble. Copper 1 hydroxide, not group 1A or 2A, so definitely insoluble. Calcium hydroxide, group 2A, soluble. Sodium hydroxide, group 1A, soluble. Lead 2 hydroxide, that's not group 1A or 2A, so it's going to be an I. Strontium hydroxide, that's group 2A, so automatically an S. Sodium hydroxide, so this applies group 1 as rule 1 as well, right? Because this is a group 1A element. So this is definitely going to be soluble because of that, and because it also applies to this rule, which says group 1 and 2 is always going to be soluble. Barium nitrate, nitrates involved, which is -1. So this is a rule 1 question basically, right? But it's a -1 charge to show you that if it's if it's a -1 charge anion attached to anything, if it's not one of the hydroxides or one of these 4, one of these 3, it's going to automatically be an S. All right, chlorides, bromides, and iodides. They form solids with silver, lead 2, not lead 4, mercury 1, not mercury 2. What's mercury 2 look like? Well, mercury 2 looks like this. Same charge, but there's no subscript. So if you see a subscript, it's mercury 1, and it's going to be insoluble with these 3. Otherwise, it's going to be an S because mercury 2 is not a part of this rule. So silver chloride, insoluble, right? Because silver, it's involved. So it's insoluble automatically. Barium iodide, it's not one of these 3, so soluble. All right, lead 2 bromide. Bromide is going to be here. There's lead 2, so it's definitely going to be an I. Mercury 2 chloride. How do I know it's mercury 2? There's no subscript here, so that's going to be an S. Calcium iodide, it's not one of these 3, so definitely an S. All right, let's move on to rule 3. Rule 3, all compounds involving anions with a -2 and -3 charge are going to be insoluble except the following. So if it has a -2 and -3 charge and rule 1 and 2 do not apply, then it's going to be automatically insoluble. Where are the exceptions? Sulfates. So sulfates are always soluble except with this: calcium, barium, strontium, and lead 2. So if it's one of these 4 and it's sulfate, it's going to be insoluble. Anything else sulfate's attached to it, it's going to be soluble. So it's a little different because this is telling you that -2 and -3 are always insoluble. But for sulfates, they're always soluble except with just these 4 exceptions. So lead 2 sulfate, there's lead 2, rule applies, so this is going to be considered insoluble. Calcium sulfate, part of the rules, insoluble. Lead 4 sulfate, not part of the rules, soluble. Silver sulfate, not part of the rules, so it's going to be soluble. All right, barium sulfate. Barium is one of the times it is a solid, so it's insoluble. Tin 2 sulfate, not a part of any of these exceptions, so soluble. Barium phosphate, -3 charge, rule 1 and 2 really doesn't apply, so it's going to be insoluble. Aluminum sulfate, sulfate with aluminum, not one of the exceptions, so S. Sodium chromate, group 1A, remember that's rule 1, so that's automatically soluble, right? Calcium oxide, calcium is not a rule 1 or rule 2 scenario. Oxide's a -2 charge, so it's going to be an I. So these are your solubility rules. So if you follow the orders in sequence, you should be able to figure out if something is soluble or insoluble.